In today's video, we are going to explore the difference between two fundamental types of physical quantities, which are known as scalar quantities and vector quantities, although they are often simply referred to as scalars and vectors. Scalars are physical quantities that only have a magnitude and do not include any information about direction. To clarify, magnitude is just another term for size or amount, and it can be expressed using a numerical value. For example, if a car is traveling at a speed of 22 meters per second, the number 22 represents the magnitude of that speed. Since the speed value does not specify a direction such as north or south, it is considered a scalar quantity. Scalars describe how much, but not which way. Other examples of scalar quantities include distance, which tells you how far you have traveled, mass, which indicates how much matter an object contains, temperature, which gives a reading of how hot or cold something is, and time, which measures how long an event lasts. These are just a few of many scalar quantities used in physics. On the other hand, vector quantities are different because they include both a magnitude and a direction, making them more descriptive and useful in many scenarios. Examples of vector quantities are velocity, which describes speed in a particular direction, displacement, which shows the change in position with a direction, acceleration, which indicates the rate of change of velocity with direction, force, which is a push or pull with direction, and momentum, which is the product of mass and velocity, and again includes direction. If any of these terms are unfamiliar, do not worry, as each one is explored in greater detail in its own separate video. To better understand the contrast between scalars and vectors, let us consider a simple example. Imagine that you begin at a point which we will call point A, and you walk a distance of 3 kilometers. Depending on which direction you walk, you could end up anywhere on the circumference of a circle with a radius of 3 kilometers centered on point A. Because you only know how far you walked, but not the direction, you cannot say exactly where you are. This is why distance is a scalar quantity. It gives no clue about direction. Now imagine instead that you said you walked 3 kilometers to the east starting from point A. That single additional piece of information, direction, now allows us to pinpoint your location exactly. In this case, the quantity you described is called displacement, which is a vector quantity because it includes both magnitude, which is 3 kilometers, and direction, which is east. In order to visually represent vector quantities, we typically use arrows. The length of the arrow indicates the magnitude, or how large the vector is, and the way the arrow points shows the direction of the vector. So, for instance, if you have a vector representing 4 kilometers to the north, it would be shown with a long arrow pointing upward, while another vector representing 2 kilometers to the west would be shown with a shorter arrow pointing left. The shorter arrow is half the length because 2 is half of 4, and the direction is to the west instead of north. We can also express vectors in negative terms when they are oriented in the opposite direction to a reference. For example, the vector that points 2 kilometers to the west could also be described as negative 2 kilometers to the east because it is essentially moving in the opposite direction of east. This is a useful way to think about vectors in terms of direction and can be especially helpful when working with vector addition or subtraction. That concludes everything we wanted to cover in this video. We hope this explanation has helped you clearly distinguish between scalar and vector quantities and understand how each is used in the study of physics. If you found this lesson helpful, then please give us a like and subscribe to the channel for more educational content, and we will see you in the next video.